Good day. Welcome to another tutorial on differential equations, ordinary differential equations. In the previous tutorials, we learned about classifications of differential equations. Differential equations can be classified based on type, namely ordinary or partial. Talk about classifications based on order, classifications based on degree, and classification based on linearity. We also checked solutions to differential equations. How do we mean when we say a particular function is a solution to a given differential equation? Today we'll continue from there. We are looking at how to obtain a differential equation from general solution. In previous tutorial we talked about what we mean by general solution, but was not well described. Here we're looking at what general solution means. If we have a function y equals c1 f1x plus c2 f2x plus ... cn fnx as a solution of a differential equation, you see this is a general solution because the arbitrary constant c1 to cn can take infinitely many values. Other way, we have a particular solution when we have a particular value for the arbitrary constant. For example, y equals e raised to power minus x plus sine x is a particular solution. y equals c1 e raised to power minus x plus c2 sine x. This is a general solution. This is a particular solution. The value of c1 in the first solution is 1, as you can see, 1. The value of c2 is also 1. So they have taken a particular value, so we call it particular solution. And when they can take several values, we call such general solution. So now to what we are for today, how to determine a differential equation from general solution. I want us to note this very quickly. The number of arbitrary constants you have in a general solution determines the order of that differential equation. Again, the number of arbitrary constants you have in a general solution determines the order of the differential equation. Let's look at this question. Find the differential equation whose general solution is given by y equals c1 e raised to power minus 2x plus c2 exponential 3x. How many arbitrary constants do we have here? 2, c1 and c2. Then the differential equation will be of the second order. So how do we go about this? The method we are going to employ in this tutorial, elimination of arbitrary constants. So we'll find a way to eliminate the constant. Any equation we'll get without the arbitrary constant is the differential equation. So since we have two arbitrary constants and we have concluded that the differential equation will be of the second order, then we need to differentiate twice. If y equals c1 exponential minus 2x plus c2 exponential 3x, then y prime equals to minus 2 c1 raised to power minus 2x plus 3 c2 raised to power 3x. If you have any problem understanding this simple differentiation, you can check my tutorials on basic mathematics for tertiary institution students. Y prime prime equals plus 4 c1 exponential minus 2x plus 9 c2 e raised to power 3x. Now we've got the two orders. We have to eliminate the arbitrary constant. So we take these as equations. Let's call this equation 1, equation 2, equation 3. We'll decide which of the constants we want to eliminate. Let's say eliminate C1. We pick two pairs of equation and solve simultaneously. Eliminate C1. Let's pick two equations. Y equals C1 exponential minus 2x plus C2 exponential 3x. And y prime equals minus 2 C1 exponential minus 2x plus 3C2 exponential 3x. Now we have these two equations. We can solve this simultaneously. Okay, since we want to eliminate C1, I'm going to use method of elimination. Multiply equation 1 by 2. So we have 2y equals 2c1 exponential minus 2x plus 2c2 exponential 3x. Equation 3. Now add equation 2 to equation 3. So what do we have? Y prime plus 2y equals, this cancels out. This plus this gives us 5c2 exponential 3x. So here we try to make c2 the subject. C2 equals y prime plus 2y all over 5 exponential 3x. We've been able to get the value of C2. We are going to pick another pair of equation. Let's pick equation 1 and 3. Equation 1 and 3. Y equals C1 exponential minus 2x plus C2 exponential 3x. Y prime prime equals 4c1 exponential minus 2x plus 9c2 exponential 3x. So multiply equation 1 by 4, so I can eliminate c1. This is a simple elimination method for solving simultaneous equation. So we have 4y equals 4c1 exponential minus 2x plus 4c2 exponential 3x. Let's call this equation 4 plus minus equation 3. Or you can say equation 3 minus equation 4, just to eliminate where we have c1. So we have 4y minus y prime prime equals, this is equation 3, minus 5 c2 exponential 3x. Don't forget equation 4 minus 3, this minus this cancels out, then this minus this gives us this. Okay, let's make C2 the subject. C2 equals 4y minus y prime prime over minus 5 exponential 3x. We now have two equations or values for C2. Since C2 is always equals to C2, we equate the two values. From the first equation for C2, we have y prime plus 2y over 5 exponential 3x equals 4y minus y prime prime over minus 5 exponential 3x. Let's do a simple simplification. We have minus 1y prime plus 2y equals 4y minus y prime prime. Minus y prime minus 2y equals 4y minus y prime prime. Y prime prime minus 2y minus 4y minus y prime equals 0. So you have y prime prime minus y prime minus 6y equals 0. This is the differential equation whose general solution was given to us. We've been able to eliminate the arbitrary constant, and here we are with the differential equation. Let's look at another example. Find the differential equation whose general solution is y equals c sine x. Now, the rule is this: the number of arbitrary constants determines the order of the equation. How many constants do we have here? 1. It means the differential equation is of order 1. So we are differentiating just once. So if y equals c sine x, y prime equals c cos x. Let's call this equation 1, equation 2. From equation 1, y equals c sine x, make c the subject, so c equals y over sine x. From equation 2, y prime equals c cos x, so making c the subject, c equals y prime over cos x. So we create the two values of c. So c equals c, y over sine x equals y prime over cos x. Simple simplification: y cos x equals y prime sine x. So you can bring this to this side: y prime sine x minus y cos x equals 0. The constant is eliminated, and here we have a differential equation, ordinary differential equation. You can go further by dividing through by sine x. You have y prime sine x from sine x minus y cos x from sine x equals 0. So have the y prime minus y cot x equals 0. I hope this is well understood. So this is how to get the differential equation from general solution. Let's look at the third example. Determine the differential equation whose general solution is given by y equals c1 exponential x plus c2 exponential minus x plus 2x. This is the general solution. How many arbitrary constants do we have? 2. It implies that the differential equation will be of the second order. So y prime equals c1 exponential x minus c2 exponential minus x plus 2. Y prime prime equals c1 exponential x plus c2 exponential minus x. If you have difficulties understanding this, you can check my tutorials, Basic Mathematics for Tertiary Institution Students. How do you go about this? There are several options, but if you can see clearly, if we subtract equation 1 from equation 3, equation 1, 2, and 3. Equation 3 from equation 1 or equation 1 from 3, we'll be able to eliminate every terms containing the constant. Let's try it. Equation 1 minus equation 3, we have y minus y prime prime equals 2x, and here we are, y prime prime minus y prime prime plus y minus 2x equals 0. We have arrived at our differential equation. It looks very simple. I hope it's well understood. Let's look at another example. Find the differential equation whose general solution is given by y equals c0 plus c1x plus c2 x squared plus c3 x cubed. The resulting differential equation should be of what order? 4. Why? Because there are 4 arbitrary constants: c0, c1, c2, c3. So it means we are differentiating 4 times. So if y equals this, then y prime equals c1 plus 2c2 x plus 3c3 x squared. Y prime prime equals 2c2 plus 6c3 x. Y prime 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 equals 6c3, and y IV equals 0. So this is our differential equation. It looks strange, but this is the answer. So y IV is the same as the 4y dx4. So the differential equation is basically the 4y dx4 equals 0. How this is well understood. Let's look at the another example. That's the 5th one. Eliminate the constant c from the equation. Okay, how do we go about this? How many constants do we have here? 1. It means the differential equation will be first order. So let's differentiate this once. I have 2 bracket x minus c plus 2y y prime equals 0. So from this we try to make our c the subject. 2 into bracket x minus c equals minus 2y y prime. Our c equals x plus y y prime. So we substitute the value of c into the main equation given. So what do we have? X minus x plus y y prime all squared plus y squared equals x plus y y prime all squared. We have a y y prime all squared plus y squared equals x squared plus 2xy y prime plus y y prime all squared. So collecting like terms, we have a y y prime all squared plus y squared minus y prime all squared minus x squared minus 2x y prime all equals to 0. So this cancels out. So we have in y squared minus x squared minus 2x y prime equals to 0. Okay, you can decide to multiply through by minus. We have x squared minus y squared plus 2x y prime equals to 0. This is the same as x squared minus y squared plus 2x y dy dx equals to 0. Multiply through by dx. What do we have? X squared minus y squared dx plus 2xy to y equals to 0. We have obtained the differential equation by eliminating the constant, and this is of the first order. Not too far from here, we're going to find out how to solve this kind of differential equation and obtain the general solution. The sixth example: eliminate beta and alpha from the relation x equals beta cos omega t plus alpha, in which omega is a parameter. Okay, this is a parameter. Why beta and alpha are constant. Okay, the differential equation of what order? Because there are two arbitrary constants, it will be of the second order. Hope this is well taken. The variable here is t. Okay, parameter w is not to be eliminated, so you won't count that as a constant. Parameter and constant are not the same. When here parameter, it means you will not eliminate it from the differential equation. So let's go. The x dt gives us beta omega sine omega t plus alpha, and put the negative sign there. If you have frame understanding this, check my tutorials, basic mathematics for tertiary institution students. The second derivative, that is the 2x dt squared, equals minus beta omega squared cos omega t plus alpha. So how do we eliminate this? Clearly, equation 1 and equation 3 have something in common. Cos omega t plus alpha, cos omega t plus alpha. If only we can multiply equation 1 omega squared and add the constant to be eliminated. Can you see that? Multiply equation 1 by omega squared. We have omega squared x equals beta omega squared cos omega t plus alpha, equation 4. So let's add equation 4 to equation 3. What do we have? This cancels out when you add. What do we have left? This 2x dt squared plus omega squared x equals to 0. Don't forget, omega is a parameter, so this is a differential equation. Hope this is well taken. Let's get the last example for this tutorial. eliminate c from the equation cxy plus c squared x plus 4 equals 0. When you are to eliminate the constant, it means we desire to know the differential equation. How do you go about this? Eliminate. You eliminate the c, but the equation will be of what order? You should know by now. We have just one constant, so it should be of the first order. So we differentiate how many times? Once. So let's go. We want to solve this using implicit differentiation method. So you keep c out, keep x constant, differentiate y, you get y prime, plus keep y constant, differentiate x, you get 1, plus when you differentiate this one, you have c2, when differentiate 4, you have 0 equals 0. So from here we have c to bracket x y prime plus y equals minus c squared, c squared, divide both sides by c, x y prime plus y equals minus c. So c equals minus x y prime plus y. So replace this in the main equation. What do we have? Minus x y prime plus y x y plus, when you square it, the negative sign goes out, x y prime plus y all squared plus 4 equals 0. You can leave it at this level but simplify it to make it look nicer. So we can factorize this, xy prime plus y, we have minus xy, there's an x here, please don't forget, plus xy prime plus y multiplied by x all plus 4 equals 0. Xy prime plus y minus xy plus x squared y prime plus xy plus 4 equals 0. This cancels out, so we have this multiplies this. I have x cubed y prime all squared plus x squared y prime plus 4 equals 0. So this is the differential equation. Let me leave it with some questions to try. Find the equation whose general solutions are given by 1. cy squared equals x squared plus y. 2. X squared y equals 1 plus cx. 3. Y equals cx plus c squared plus 1. 4. X cubed minus 3x squared y equals c. 5. Y sin x minus xy squared c. And 6. X equals c1 cos omega t plus c2 sin omega t, where omega is a parameter. I hope you will not have problem solving this. This has brought to the end of another tutorial.